In this lesson, we're going to look at section 11.3, which is circles in the coordinate plane. So it's essentially looking at the equation of a circle, which we can find here in this formula. So notice that you should have some familiar values here. So h and k, we know from graphing parabolas. So if I have h and k, those are the coordinates of the center. And so then if I look at the equation, x minus h, y minus k, this part's different because h and k are both in parentheses. So the value in the point, so this is my center point, is going to be the opposite value in the equation for both h and k. And so we talked about the reason that we always did the opposite for h is because it's x minus h. This one's also y minus k. So that part is different from a parabola because k was outside of parentheses. It wasn't being subtracted by a variable. And then that's going to be equal to r squared. So the radius is going to be equal to the square root of that r squared value. So the number in the equation isn't the actual radius of the circle, it's the square of the radius. Just to kind of go to the most basic example that we have today, I'm going to skip down to example 4 and use this formula. So I'm going to rewrite the equation of a graph. So the equation of the graph of a circle is x minus h squared plus y minus k squared equals r squared. So looking at this, minus h, right, is going to give me the value of h. So this is telling me that h is 3. And then y minus k is positive 4 in this one. So this is telling me that k is negative 4. So again, it's the opposite. So that means that the center of my circle is at 3, negative 4. So I know that that's going to be a point on my graph. So if I plot the point at 3, negative 4, that is going to be the center of the circle. R squared is 9. So that means that r is the square root of 9, or 3. So the radius of this circle is 3. When I'm graphing something for a circle, I'm going to count out that radius to either side of my center and also above and below. So I kind of make this plus sign shape. And then I would just connect that into a circle as best I can. It's obviously not going to look very great because I'm not drawing a perfect circle. When you're doing this on a graphing tool in either Realize or Edge Elastic, you're going to plot the center first, and then you can plot just one of the points, and that'll create the entire circle. So it will do the rest for you. You only have to go out the radius in one direction. Okay, so that is taking an equation and graphing a circle. You might see problems that ask you to just go from the information, so like this piece, the center radius, and to be able to write the equation, or to take the equation and just identify the center and the radius as we did. So I'm not doing a ton of examples with those things. I'm doing more of examples with the harder pieces. So feel free to ask questions as you're working on the assignment if something is confusing you within the equation and how the equation relates to finding the center and the radius. And then you will be graphing using digital tools for this. Okay, so let's go back up to the beginning. Actually, let's just go to example 3. So if example 3 says that circle Q has a radius of 7 and is centered at the origin. So if I'm thinking about that, that means that it's centered at the origin and has a radius of 7. So it would take up like this whole area, right? If I was drawing that circle. I know I'm doing this in yellow because I don't want you to copy it. So it would be that circle. And so they're giving me a point and they want me to determine if it lies on that circle. So what I want to do is to determine if the equation works for that point. So the equation of a circle we know now is x minus h squared plus y minus k squared equals r squared. So if this circle has a radius of 7, they're telling us r is 7. Okay, so I know that I can plug 7 in here. So I have 7 squared here. And that it's centered at the origin. So the center is 0, 0. That's the origin. So h is 0 and k is 0. So what I can think about is that if a point lies on the circle, this equation would be true when you plug in all the values. Okay, so all values, I mean that this is a coordinate of a point, right? This is x, comma y. So if I plug in negative 3 radical 2 as x, I forgot my minus sign, and I plug in 5 as y, I now have plugged in a number for all of the unknowns in the equation. And so I can simplify this by typing all of this into my calculator. So I'm going to take in my Desmos Scientific Calculator and type the left-hand side in. So I've got negative 3 radical 2 inside parentheses minus 0 squared plus 5 minus 0 squared. And so that gives me, it's off the screen, 43. Okay, so that means that if I calculate this, that's 43. If I calculate 7 squared, that's 49. So what I'm looking at is, are these equal? So if they were equal, then my answer would be that they are on the circle. In my case, though, it's less than 49. So if it's less than 49, I can say for sure that it's not on the circle. But further, what I can say is that since 43 is smaller than 49, if this was my 7, this would be smaller than 7. It would be somewhere between 6 and 7. So if I get a smaller number, it's actually going to be inside the circle. We might have some things that ask us this. And then if I had a bigger number on the left, then it's going to be outside the circle. Okay, so I can think about this number on the left as the radius of the circle that would be on. So the radius of the circle that the point negative 3 radical 2 5 is on would be square root of 43, which is smaller than the square root of 49. So it's going to be a smaller circle that one is related to. Okay, so I'm plugging in all the values for h, k, r, x, and y, and I'm looking at the comparison of the left-hand side versus r squared. Okay, so then this one is going to be kind of similar to that, and the graph mixed together. So they've given us a graph, and they want us to write the equation. So remember, to write the equation, we need to know the center, which in the diagram, it looks like A is the center, negative 1, 2. And we need to know the radius. And in this diagram, the radius is a diagonal line. So I can't just count the radius. If I try to count, I can see it's 3 point something because this would also be r. And so I can estimate r, but in order to find its exact value, I need to use the equation. So knowing the center, I know that h is negative 1 and that k is 2. And so if I wanted to write my equation, so I'm going to set up my answer, I would do x minus h squared plus y minus k squared equals, I still need to figure out r squared. So I don't know the radius at this point, right? I need to figure that part out. And so here, since h is -1, I would plug in the -1 here, so that would turn into +1. And k is 2, so I would plug in a 2, so it's y minus 2 squared. Okay, so I know the left-hand side of my equation of my circle. What I don't know is the radius. So to find the radius, what I can do is exactly what we did on the left-hand side of example 3, because that's equivalent to r squared. So if I take my equation, x minus h squared plus y minus k squared, that's equal to r squared, which is exactly what I need to be able to plug in here. So they do give me another point on the circle. So remember that the point in the last problem we talked about, it's x and y. And so that means that in this problem, I can plug in 1 for x and I can plug in 5 for y. So I'm going to do x minus h squared plus y minus k squared in order to find my r squared. So we already know that h is -1, so we're going to do 1 plus 1. And then we already know that k is 2, so 5 minus 2. So we're going to type this in. We could probably do this one in our heads, though, because it's whole numbers. So let's just calculate that. So 1 plus 1 is 2. So 2 squared will give us 4. And then 5 minus 2 is 3. And so 3 squared is going to give us 9. So r squared is equal to 13. So r squared is exactly what's in the equation. However, if they asked us what the radius was, right, if they wanted to know the radius, we would have to square root to find the radius. So the radius is the square root of 13. But the number in the equation is just 13 because that's r squared. Okay, so then the last problem has to do with the application of circles. And it's related to Doppler radar because it detects precipitation within a 90-mile radius. Doppler radar here in Grafton and Myersville does not extend to Clear Lake or Davis. Where can a third Doppler station be placed so all towns are covered? So I know that your copy doesn't look great in terms of these values. So if you can see mine, I have obvious tick mark lines. So this is going by 30 miles. So one box represents 30 miles. So if there's a Doppler in Grafton, it's going to go 90 miles, which would be 3 boxes in either direction. So it would go to Greenville and then up 3 to the end of the word Grafton, and then down to right between Fairfield and Clear Lake. So if I draw this circle, it looks like it should go through Haverford, cover Fairfield, Greenville, and Grafton. Okay, so it looks like those 4 cities would be covered with that Doppler. The other Doppler is in Myersville. So Myersville, if that was the center, if I go out 3 boxes in either direction, to the right gives me nothing. Up 3 is Maple Plain, and then left 3 and down 3 is going to cover, it looks like Menorah and West Elm. So the Myersville covers those 3. So we can see that Davis and Clear Lake are not covered in the Doppler. So what I can think about is that if the Doppler radar covers a 90-mile radius, it would cover a diameter of 2 times 90. So it would need to cover 180 miles. And so if I think about this, I can determine how far apart Davis and Clear Lake are if I identify the right triangle that creates them. So I'm going to resketch this right triangle here. So this is Davis and this is Clear Lake. As long as they're 180 miles or less apart, we will be able to put a Doppler to cover their area. So this is 1, 2, 3, 4, 5, 6 boxes across. So that means that it is 6 times 30, so 180 miles. And then this is 1, 2, 3, 4 boxes, so it's 120 miles. So actually, without even solving this, don't I know that the distance needs to be bigger than 180 because it's literally the hypotenuse, which is the longest side. So the distance between Clear Lake and Davis is more than 180 miles. Again, that's the maximum that one Doppler covers, right, is 180 miles total, 90 in each direction. Since the distance, the horizontal leg of this right triangle that we created is 180, the hypotenuse has to be bigger than that. So adding one more Doppler will not cover both cities. Okay, so we would have to place 2 Dopplers in order to reach those additional cities. Okay, so that is everything for equation of circles. Remember, you're always relating it back to this x minus h squared plus y minus k squared equals r squared. Some of your problems will be very basic, giving the center and the radius and writing the equation, or taking the equation and writing the center and the radius. And then they will get to become more complicated, like the other examples that we did today.